So this is another same example that we did earlier today, but this time we're going to figure out what the minimum velocity is needed in order to clear the fence and hit a home run instead of the minimum angle. Again, I have a system of equations, and so I can choose to either get t by itself or the velocity by itself. I think for this one, I'm going to get the velocity by itself. So I'm going to get 400 over cosine 18 degrees times t, and that's going to equal my initial velocity. And instead of doing 400 divided by cosine 18 degrees t, I'm going to keep it in that exact form first, and then I'm going to plug it into my initial velocity right there. So my other equation is going to become 20 equals negative 16 t squared plus 400 over cosine 18 degrees times t times sine of 18 degrees times t plus 3. So solve the first equation for initial velocity, plug it into the second equation, figure out the time. So that'll give me the time it takes to get to that initial velocity, and then I can plug that in to get the initial velocity. And I could have done it differently. I could have solved for t and then plugged in for t. I think that would have given me another quadratic I had to work out. Maybe I still have a quadratic to work out, but this is the way I chose to do it. Now, something to point out. In my parentheses, I have a factor of t on the bottom. And outside my parentheses, I have a factor of t as well. So t will cancel out with t. I also have a cosine 18 degrees and a sine 18 degrees, so I can write that differently because sine 18 divided by cosine 18 is tangent 18. I can subtract 3 on both sides, and so I have 17 equals negative 16 t squared plus 400 tangent 18 degrees. And that's it. Sine over cosine is tangent. I have the 400, the t factors have already canceled, and I subtracted 3 on both sides. So I could subtract that. 17 minus 400 tangent 18 degrees is equal to negative 16 t squared. If I divide by negative 16, I'm just going to get t squared equals, and so t equals plus or minus the square root. But we're really just looking at the positive square root because we want positive values for time. So square root of 17 minus 400 tangent 18 degrees divided by negative 16. I'm going to get 2.657 seconds. So I want the initial velocity. If I take my original equation, 400 equals initial velocity in terms of cosine 18 degrees. Times time. And I plug this in. Okay, or let's see, did I get a time by itself equation? I had an initial velocity equation. Let's do that instead, because that's going to be the same thing. So right here, 400 divided by cosine 18 degrees times t. Just be careful with your calculator. 400 divided by, or 400 over cosine 18 degrees. Close my parentheses, times my previous answer. And I get 158.28 feet per second. And so that's the initial velocity needed. Instead of hitting the ball at 150 feet per second, if I hit the ball and it leaves my bat at 158 feet per second, I can clear the fence. And then the next example we're going to do, just keep it one video. An archer releases an arrow from a bow at a point 5 feet above the ground. The arrow leaves the bow at an angle of 15 degrees with the horizontal has an initial speed of 25 feet per second. How long is the arrow in the air? How far does it go? What's the maximum height? So answer all the things. So let's come up with our equations first. So my x of t, the horizontal distance that the arrow is going to travel, has a 225 feet per second. So we're going to do the initial velocity, 225 feet per second, times cosine of the angle, cosine of 15 degrees, times time. And then my y value for the vertical distance that the arrow is traveling starts at 5 feet. We also have the negative 16 t squared plus 225 sine 15 degrees times t plus the initial height of 5 feet. So there is my model that I'm going to use. How long is the arrow in the air? So that first question, how long is it in the air? I can set my vertical height equation, my vertical distance equation, equal to 0 and solve that. Now that is a quadratic equation. And so I could do the quadratic formula. T equals negative b, so negative 225 sine 15 degrees, plus or minus the square root of 225 sine 15 degrees squared minus 4 times negative 16 times 5, all over 2 times a, so negative 32. So let's plug that in our calculator and see what we get. Negative 225 sine 15 plus the square root of 225 sine 15 squared minus 4 times negative 16 times 5, all over negative 32. I got a negative number the first time. So we're not going to use a negative number. So I just need to go through my square root equation I just did and typed in and change it to a minus square root instead of a plus square root. I got 3.72. So it took 3.72 seconds for the arrow to hit the ground. Seems like a long time. The next question is, how far does it go? So what's the horizontal distance traveled? So what is x at 3.72? But really, I'm just going to plug my answer from my calculator in there. So I'm going to use the stored value. So 225 cosine 15 degrees times the answer from my calculator. 225 cosine 15 times answer. I'm going to get 809 feet. 809.3 feet. What is the maximum height of the arrow? So for the maximum heights, keep in mind what we have is a quadratic. What some people do is they'll take where it hit the ground at 3.72 seconds, and they'll say, well, the maximum height is half of that. But that's actually only true if you have a projectile motion that starts at the ground. So if I start at the ground and I come back to the ground, then yes, the vertex will be the exact middle of those 2 points. So half the time. But if I start up in the air, like 5 feet in the air, then my center is going to be halfway between this other number that I don't know and 3.72. Now I could use this negative 0.8 and 3.72. I could use both of those values. So t at the vertex is going to be negative 0.08 plus 3.72 divided by 2. So I'm going to use this exact values again. That's 1.82 seconds. So then I can find, well, what is y of 1.2? 1.82. So negative 16 times my answer squared plus 225 sine 15 degrees times my answer plus, what did I do? Start at 5 feet. So I could do it that way. Just going to plug that into the calculator. Use the answer key. And I got about 58 feet. Another way to do that is to take my equation for my vertical height versus time and just find the vertex. So we have a vertex formula back from algebra 1, x equals negative b over 2 times a. And so you could do that as well. Besides finding the two intercepts, you could do that. So 225 sine 15 degrees is negative b. So negative 225 sine 15 degrees over 2 times negative 16. That should give us this 1.82 number, unless we made a mistake. It's negative 225 sine 15 degrees divided by negative 32, and I got 1.82. And then I can plug that into the y. So there's a couple different ways you can get the vertex. What's the maximum height of the arrow? 58 feet. So they shot that thing pretty far up. So that 15-degree angle, like this person's probably not shooting, you know, a 50-yard target down the shooting range line. I don't know what they're shooting at, but it's going to go pretty far. You know, this going 800 feet. It's almost 100 yards. Anyway, that's the maximum height of the bow or the arrow and the time that it took place. So those are just a couple more examples for you to look at.